So this is kind of a fun one. We can use some statistics and probability. First, let's introduce what's going on here. So a little bit of background, depending on where your probability is at. I'm assuming this is new for most of you. But if the average time between two events is some number k, we can model that time between events as some random variable that we call x. So x is random, it's a variable, there's certain probabilities of what it might be, but we don't know what x is going to be. And it's going to be a continuous distribution, different from a discrete distribution. Discrete would be if there's only like individual values that this time could be, but continuous will be, it could be everything in that interval. Then we have a continuous distribution here. It's known as an exponential distribution. Then the probability that x, the time between those two events, which on average is k, is that average time, but the probability that x is between some number a and b is given by this formula, where the probability that x is between a and b is just the integral of some function f, which is known as a probability mass function. You don't need to know that, but probability mass function, or PMF. Then here, f of x for an exponential distribution is a piecewise function of this form. So we're going to use that to answer a question. Here's the actual question. That's just the background. There's some dangerous intersection in some city, and it had an accident occur about once every 3 months. So people weren't happy about that, and so they modified the traffic lights in a way to make it hopefully more safe. And since then, 8 months have gone by with no accidents. Is this good evidence that the changes were effective? So there's not really an obvious calculus here. Let's rephrase this question a little bit to give us some way to do calculus. Let's frame it a different way. What are the chances that we could have gone 8 months without an accident? Oh no. The natural way for me to phrase this question actually doesn't have anything to do with improper integrals at all. What are the chances that we could have gone 8 months without having an accident? Oh no, this works out. Okay. Well, that means that the time between accidents must be at least 8 months, right? Let's say, let's look at before the change. If the change wasn't effective, right? If the change wasn't effective, then we can use this information to find the probability of this happening. What's the probability before the change? Let's think about it that way. Before the change, if there was an accident every 3 months, what's the probability of going at least 8 months with no accident? Right? What's the probability of going at least 8 months with no accident? And let's look at this before the change. And if this probability is common, then we would say, well, there's no evidence that the change was effective. Maybe it was, maybe it wasn't. But if this were like, 50%, for example, if this is an everyday occurrence that, yeah, it happens on average every 3 months, but going 8 months at least without no accident, that's pretty normal. Then that doesn't tell us anything. This could have happened, who knows? But if an accident occurring every 3 months, the probability of this happening, of going 8 months without, if that was like 0.05% or something, that would be really a rare occurrence. And we'd say, oh, maybe these changes were effective. So that's the overarching statistical logic for what we're going to do here. So let's calculate this probability. Probability that something is between a and b is the integral from a to b. Well, this is not written from a to b. What is this? That's from 8 to infinity of f of x dx. What is our f of x here? Our probability mass function. What's k? If the average time between two events is k, the average time between two events is 3 months. Okay, so k is equal to 3. Right? Our units of x are months. So it's a piecewise function, but notice this piecewise function has one piece for negative x's and one piece for non-negative x's. Well, we're only looking at non-negative x's, so we can just use that piece of f. We don't have to use the other piece. And instead of writing infinity, let's write it as a limit. We need to do that. It's an improper integral. So it's going to be k e to the negative k x. That's our probability mass function. Well, now we just evaluate this integral. It's the limit as b goes to infinity. Not only does the 3 come out in front of the integral, it also can factor out in front of a limit. Remember your properties of limits. Now we have the integral from 8 to b of just e to the negative 3x dx. We can take that antiderivative, no problem. It's going to be negative a third e to the negative 3x. We can do that with a u substitution, evaluated from 8 to b. U would be negative 3x. Du would be negative 3 dx, if we did that u substitution out. Okay, well, and again, right, we can factor this constant out in front of the limit. What's 3 times negative a third? Well, it's negative 1. And then what's left is e to the negative 3x, evaluated at b, minus e to the negative 3x, evaluated at 8. What is this? As b is going to infinity, this is an exponential decay function, right? This is the function y equals e to the negative 3x. So as x is going to infinity, or as b is going to infinity, what is happening with this function? It's going off to 0. This limit is 0. And we're just left with e to the negative 24. Wait, this answer is way too small, no? Nope, it's right. We get e to the negative 24. What's e to the negative 24, guys? Let's use a calculator. E to the negative 24. 3.78 times 10 to the negative 11th. That's 10 zeros. That's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 7, 8. Or you could write 3, 8 if you wanted to round. Is this likely? Is this a likely probability? I think not. This says that if we didn't make the change, the probability of this happening at least 8 months going by before an accident would have been practically 0. This, for all intents and purposes, is 0, probabilistically speaking, for most things. All right. Well, I guess those changes were effective then, because we're operating on the assumption that if there were no changes, this would be the probability. So either our formulation's wrong, which it can't be because we got it from the book and the book is never wrong. Either that's wrong or these changes were effective. All right. Almost impossible that this could have happened without changes. So we conclude the changes were effective. And there's a bunch more probability questions that you could ask within this framework. What's the probability before the changes went through that we went less than 2 months without an accident? Then you integrate from 0 to 2. Okay. Or you could ask all sorts of questions along that line. You could verify that it's a probability distribution. If you integrate over the entire domain, you should get that the integral is 100% or 1. You could do that too. But that's a good start. And then there are more problems like this on the homework. Best of luck. Bye-bye.